Hello there. Bobo the Bitcoiner is back. We are now in episode number 5. The last time we talked about Bobo sent one Bitcoin to Cha on the surface, on the internet part. Now let's look into how the Bitcoin ecosystem handle when Bitcoins was sent. So Bobo will go into his crypto wallet and instruct with the message 1 Bitcoin to be sent to Cha's public key. The system will then take the message and generate a transaction ID. All right. This is a transaction ID with the amount of the transaction, the address, that means to say my private key and the Cha's public key, and the timestamp. Timestamp means the date, time, and second this transaction is created. This will be signed in together with a digital signature. A digital signature is unique only to this transaction that I'm doing. Even if I were to create a second transaction, it will generate a different digital signature. So each transaction comes with a unique digital signature. Now, all the nodes in the Bitcoin ecosystem will then verify the transaction ID by ensuring that Bobo's wallet do have the 1 Bitcoin and also do not overspend or double spend. You see, Bobo's wallet may have only 1 Bitcoin, and if he send that to 1 Bitcoin to Cha and try to do another transaction by sending another Bitcoin to let's say Aseng, this is double spend. All right. In both cases, the system will check that Bobo wallet is verified, transaction is considered as true and correct. No double spend, he has enough Bitcoin in his wallet. Otherwise, the transaction will be thrown out. All right. Now, the correct, once it agree and recognize that the transaction ID is okay, it then broadcasts to the whole ecosystem, all the Bitcoin network nodes. Then, every computer, every node will then run the transaction ID on its protocol and generate a value hash. This is what I mean. With the input of the message, it went through the hash function. It generates what you call a hash value. Every node in the Bitcoin system with the same input message will definitely come up with the same hash value, because it's mathematically, cryptographically programmed that way. There can never be a different answer. Every node value hash must be the same. All right. A slight change in the transaction in the message will totally result in a completely different value hash. Example. You see, the message is here. I send 1 Bitcoin to Cha. It will go through the cryptographic hashing. and then it generates the hash result. All right. If I were to take the same message and add in slightly one thing, like in this case, the message is the big brown fox jumped over the lazy dog, and if I were to add in a full stop behind, same sentence, one full stop, going through the same hash function, you see the result is completely different. Totally two different unrecognizable characters. This is the power of hashing. All right. Every unique message come in will come up with that unique hash value. Now come the consensus function again. So every node will generate a hash value. The system will counter check all the nodes. You know, the Bitcoin ecosystem, they counter check almost every second, every instant. It's run 24/7, non-stop. The software is run continuously. Now, when the system counter check all the nodes, whether all has the same hash value, all right. If all is the same, then the system will recognize this as true and correct. All right. This is consensus, majority decision. Now, every node or every computer is identified by one IP address, right? So, in the case of consensus, the majority is based on one IP address, one vote. So, all the nodes will create a hash result, and the node will be the node's result will be checked. If all agree is the same result, that transaction is considered true and correct and go to the next stage. All right, this is called trustlessness. No human involvement, no need to trust anyone. It's a machine decision. Okay, there may be some node that came up with a different hash value. Maybe that node software is corrupted or being tweeted, altered, or hacked by somebody. That node will be thrown out, and the IP address of that node will be banned from the ecosystem. All right. So you can see here, how could a hacker corrupt the majority in today's millions of nodes at Bitcoin network? Simple, right? Majority over minority arithmetic. Clever. So when this transaction has been verified as true and correct, then you move to the next session. It's moved to a place called, where the hell is that? Mempool, but it's okay, not written here. Mempool is a place where all the transaction has just been verified, waiting for the next stage of another certification. And that stage is called proof of work, or in simple language, Bitcoin mining, which is a very, very important function. All right. The next episode, I will explain the actual work of Bitcoin mining, proof of work. Okay. So stay around. See you again. Bye bye.